The emergence of quantum computing is poised to revolutionize cybersecurity, presenting both unprecedented threats and opportunities for ethical hackers tasked with defending digital infrastructure. Unlike classical computers that process bits as zeros or ones, quantum computers leverage qubits, capable of existing in superposition and entanglement, enabling them to solve complex mathematical problems exponentially faster. For ethical hackers, this paradigm shift demands a fundamental rethinking of cryptographic defenses, as quantum algorithms like Shor's algorithm can theoretically break widely used encryption standards such as RSA, ECC, and AES 256 in seconds, rendering traditional public key infrastructure obsolete. However, quantum computing also introduces novel defensive mechanisms, such as quantum key distribution (QKD), which uses the principles of quantum mechanics to create theoretically unhackable communication channels by detecting any eavesdropping attempts through quantum state disturbances. Ethical hackers must now prepare for post-quantum cryptography, PQC, a new generation of algorithms designed to resist quantum attacks, including lattice-based, hash-based, and multivariate cryptographic schemes currently being standardized by NIST. The evolving threat landscape requires ethical hackers to expand their skills beyond conventional penetration testing to include quantum vulnerability assessments, identifying systems still reliant on classical cryptography that will become vulnerable once quantum computers reach sufficient scale. Organizations must conduct crypto-agility audits to ensure their systems can transition seamlessly to quantum-resistant algorithms, a process ethical hackers will facilitate through risk assessments and migration planning. Additionally, quantum computing introduces new attack surfaces, such as quantum side-channel attacks, where adversaries exploit power fluctuations or electromagnetic leaks from quantum processors to extract sensitive data. A vulnerability requiring ethical hackers to develop new mitigation strategies. The rise of hybrid quantum classical attacks further complicates defense, as cybercriminals may use quantum computers to crack encryption while employing classical methods like phishing or zero-day exploits to infiltrate networks. To stay ahead, ethical hackers must familiarize themselves with quantum programming frameworks such as Qiskit by IBM, Cirq by Google, and QHash by Microsoft, enabling them to simulate quantum attacks and test quantum-resistant defenses in controlled environments. Open-source quantum emulators like Project Q and Penny Lane provide accessible platforms for experimenting with quantum algorithms without requiring physical quantum hardware. Bug bounty programs are also adapting, with platforms like HackerOne and BugCrowd expected to introduce quantum security challenges, incentivizing researchers to uncover flaws in post-quantum cryptographic implementations before malicious actors exploit them. Beyond cryptography, quantum computing enhances AI-driven cyber threats, enabling attackers to optimize malware using quantum machine learning or brute force password cracking at unprecedented speeds. Ethical hackers must leverage quantum-enhanced threat detection, employing quantum machine learning models to identify anomalies in network traffic or predict zero-day exploits with greater accuracy. Governments and enterprises are already investing in quantum red teaming, where ethical hackers simulate quantum-powered attacks to stress-test critical infrastructure, financial systems, and national security networks. The ethical hacking community must also address quantum hacking, exploiting imperfections in quantum hardware, such as photon detectors in QKD systems, or calibration errors in qubit operations. Research has demonstrated that even quantum-secure systems can be compromised through laser blinding attacks or timing-based exploits, necessitating continuous adversarial testing. Collaboration between quantum physicists and cybersecurity experts will be crucial to developing robust countermeasures. As quantum computing transitions from theory to practical application, ethical hackers must advocate for responsible quantum disclosure policies, ensuring vulnerabilities in quantum systems are reported and patched before widespread deployment. The future of ethical hacking in the quantum era will demand interdisciplinary expertise, combining cybersecurity, quantum physics, and advanced mathematics, to safeguard a post-quantum world where traditional defenses may no longer suffice. By proactively adapting to this technological revolution, ethical hackers can ensure they remain the vanguard of global cybersecurity, mitigating quantum threats while harnessing quantum advancements to build more resilient systems.